Hey, Mayfield grade 10s. This is Mr. Ray again. We're going to do another type of quadratic word problem. This time we're looking at a geometry type question using a rectangle. Okay, these are actually quite common questions. You'll see a few of these in the handout besides the one we're doing. I'm going to take question 13 from the handout, which is right here. It says a rectangular lot is bounded on one side by a river and on the other three sides by a total of 30 meters of fencing. The area of the lot, a square meters, can be calculated in terms of its width, x meters. Calculate the dimension of the largest possible lot. Okay, sounds a little bit confusing when you hear the first one, especially with the river. But again, extremely important. Draw a little diagram what's going on. So we've got the river. This is looking from above. And we've got our rectangular lot that's up against the river. So the shape of the lot is rectangular, but we're actually only looking at these three sides of the rectangle because we only need to fence these three sides. Okay, it tells us that we have a total of 30 meters of fencing. So the 30 will take up there. We're going to use all of it, nothing more, nothing less. It's going to always add up to what they tell us we have. And they tell us, well, they told us to use the variable x. They don't necessarily have to. When I look at this, if they didn't tell us that, I would say, okay, I need to know what this length is and this length or width, however you want to call it. So basically I'm looking at that dimension and that dimension. I always look at it as, well, there's two of these and only one of these. So I'm going to take the easy way out. I'm going to make that my variable because there's two of those sides. Okay, you could do it the other way, but it's a little bit more work. So being lazy sometimes is worth it. So we have to figure out, well, what's over here then? So you have to think about, you've got 30 meters of fence. And by putting an X here and here, that says I'm using X meters of fence there, X meters of fence there. So that means I've used 2x meters of fence. Okay, so how much do we have left for that third side? This is just simple math. We subtract. We started with 30 and we took away 2x meters. Okay, so that's how much we have left over once we've used those. So that 30 minus 2x is actually, it's going to go there. Now, easy way to check if you've done this right. If you add up these three sides, it should add up to 30 meters. So I've got x plus x, which is 2x, plus 30. So 2x plus 30 minus 2x. Well, the x's all cancel, and you've got 30. So you know you're right because you added them all up, and you've got 30, which is how much fence you should have. Okay? If you add an extra x in there or something, something went wrong. Okay, now, it says here we want to create the largest possible lot, which means area. Okay, we want the largest possible area. So I'm going to start off just a basic area of a rectangle is length times width. Okay, and I know, well, I'm going to call this my length and not my width. It doesn't really matter. So that's going to be x times 30 minus 2x. Okay, so where do we go from here? Because I'm trying to find the largest area. I don't really know that. I don't really know x. That's what we're trying to find. So I can't solve this because I got two variables. So one thing you can do here, definitely expand this and then you can complete the square. That will work, and that's what a lot of people prefer. That's the way I used to teach this type of question, but I find a much easier way is to look at it from this way. So if I do a little sketch, this is what the area is based on what one of the sides is. So you can tell from this that the area is going to be a quadratic. It's going to open down because I'm going to have a minus 2x squared. So it's going to be some parabola that opens down like that. Okay, so what I'm looking for is that value of x, which will give me the largest possible area. Okay, so I'm trying to find that point, at least that value that will give me that point. Okay, so like I said, you could complete the square, change it to vertex form, find the vertex, no problem. So if that's the way you'd like to do it, go for it and find the vertex, and that will give you the x value and the a value. Okay, I'm going to show you a slightly different way, and that's the relationship of the vertex. Okay, so on the bottom here, that's where the area is 0. Okay, so if I can find these 2 points, the 2 values of x that make this area 0, then the midway point between those will give me the value of x for the vertex. And it's actually, this is totally a great place to use it, because if you look at this, this is already in factored form. So if it's in factored form, it's fairly easy to find the zeros. We just set the area equal to 0 and then set each factor to 0. So if I set that to 0, well, that's just x equals 0. If I set that to 0, 30 minus 2x means 2x is 30, and that means x is 15. Okay, so that means that's a 0 here and that's a 15 here, which tells me for the vertex, x is equal to 0 plus 15 over 2, which is 7.5 meters. Okay, found that very quick. And that's because it's in factored form. Set the area to 0, solve for the factors. We get the zeros, and then we get the midway point is where the vertex will be, the axis of symmetry. Okay. So we basically answered the question. X needs to be 7.5 meters. So therefore, for maximum area, x is 7.5 meters, which means, if I go back to the picture, so if that's 7.5, well, that's going to be 30 minus 2 times 7.5. This is going to be 15. So the dimensions will be 7.5 by 15. And that's all meters. 7.5 meters by 15 meters. Now it doesn't specifically ask in the question. It just says calculate the dimensions of the largest possible lot. A lot of questions will say what is the largest possible area of this lot. In this case they didn't, but it's super easy to calculate because, you know, we could just look at, well, that's a 7.5, that's a 15, so it's 7.5 times 15. Same thing here, 7.5, 15, and then that gives you an area. We don't have to answer this in this question, but in a lot of questions you will, producing an area of 112.5, and don't forget the units are meters squared. Oops, sorry about that. Maximum area, x is 7.5, so that makes the dimensions 7.5 by 15 meters, and the area is going to be 112.5 meters squared. Okay, so this was a bit of an odd question because of that river, okay? But you have a lot of questions where there is no river, so how would you do it differently? Okay, we kind of call these a three-sided rectangle question, which sounds impossible, but the shape is a rectangle, but we're only dimensioning for 3 sides. That's why it's three-sided rectangle. We have questions like this where you maybe build a, an animal pen up against a barn. So this would be a barn instead of the lake or the river. So you only have to use fencing for 3 of the sides. So it is a fairly common question, but a lot of times you'll be building a pen which needs all 4 sides dimensioned. So how would you do it differently? Well, I would start off the same way. Obviously this will be dark because we're using it. Call these 2 sides x. So if I start with 30, I still use 2x. So I have 30 minus 2x left over. This time I need to have 2 sides that use that. So what I have to do with this is I have to divide this remaining fencing by 2. So 30 minus 2x over 2, that would be 15 minus x. Okay, and so this side would become 15 minus x. This side would become 15 minus x. And then your equation down here would just be this changes to 15 minus x. Okay, so when you do your 15 minus x, so x would be 15. I think it works out the same, but I'm not 100% sure. But that's how that changes. It's just if you have the fourth side, then whatever's left over from the fence that you used on after you've dimensioned two sides, you have to divide that remaining length by 2. And so basically, if you added these two sides up, you get 30 minus 2x. So this would be 15 minus x. 15 minus x. This equation changes. And this diagram will change slightly, I think. But that's how it's different if you have a four-sided rectangle instead of this three-sided rectangle problem.